In this lesson, we are going to be multiplying radicals. We will be able to find the product of any two radical expressions. Remember the rules that there are no perfect squares to be left under the radicand, there are no radicals to be left in the denominator, and there should be no fractions or decimals under the square root. Please remember you are either in jail or out of jail. That means that if we have an expression that looks something like this, 3 square roots of 2, that we have two different pieces to this expression. We have the number that's outside and we have the number that's under the radical. And you can apply the multiplying and dividing properties of numbers if the numbers are both under the radical or they're both outside. Then they can either be multiplied or divided as long as they are the same type of number. So let's take a look at some examples first. Evaluate for the given values of A and B. So if I have two numbers that are under the radical, A times B, I can take 4 times 9, and that's going to be the square root of 36. Because both numbers are under the radical, I can multiply them together, and that's going to be 6. In this example, I have the square root of 4 times the square root of 9, and I can take the square root of 2, or square root of 4, which is 2, and the square root of 9, which is 3. I can take the square root of them first, and then multiply them together, and I'm going to get the same answer. Let's look at another example. If I have 25 times 4, and they're both under the radical, that's going to be the square root of 100 because I can multiply them together when they're both underneath, and the square root of 100 is 10. It also works if I were to separate the two and take the square root of 25 first and then multiply that by the square root of 4. The square root of 25 is 5 and the square root of 4 is 2. The product will be 10. One more example. If I have the square root of 4 times the square root of 36, I'm going to take 4 times 36, which is 144, and the square root of 144 is 12. We could also take the square root of each of these numbers separately. The square root of 4 is 2 and the square root of 36 is 6, and when I multiply the two together, my product is 12. So, we are going to simplify and we are going to multiply. Let's do some simplifying to practice. So, let's make a factor tree for 300. Let's do 30 times 10. And then we can do 5 times 6 and 2 times 3. And we can do 5 times 2. So we are going to rewrite our radical and we're going to put our factor pairs underneath. I have 2 5s, I have 2 2s, and I have a 3. When I bring the 5 out and the 2 out, because remember that taking the square root of a squared number are opposite operations, I need to make sure I remember that they are all being multiplied when they come out. So I have 5 times 5, which is 25, times 2, which is 50, square roots of 3. Let's take a look at our next example. I have 3 times the square root of 125. The square root of 125 is 25 times 5, and 25 is 5 times 5. So I have 3 times the square root of listing my factor pairs as 5 squared and 5. So the 5 can come out of the radical, the 3 was already there, and we leave the other 5 underneath. So simplified, I have 15 square roots of 5. In our next example, we have the square root of 66 times the square root of 15. Because both of these values are under the radical, they are alike and we can multiply them together. 6 times 15 is 90. Then we have to simplify. So we take 9 times 10, then it can be 3 times 3 and 2 times 5. So when I rewrite my radical with my factor pairs, I have 3 squared times 2 times 5. I can bring the 3 out, and the 2 times 5 stays underneath as 10. Some of you may be getting to the point where you can go directly from this part of the prime factorization and recognize that these 3's are in a pair, so the 3 comes out, and the 2 and the 5 stay underneath, which is 10. Next, we take 13 times 52, which is going to be the square root of 676. Or what we could do is we already realized that we could put these two together underneath the radical, and we can start making our factor trees right away. So we have 13 times 52. 52 can be broken down into 2 and 26, and 26 can be broken down into 2 and 13. So when we rewrite the radical, we're going to have 13 squared and 2 squared. Both of those can come out, so we have 13 times 2, which is 26, and we don't need the radical any longer because there was nothing underneath. Some of you may want to multiply this together right away, which is 676. Some of you might recall that that's 26 times 26, that 676 is a perfect square, but most of us would have had to do the factor tree to figure that out. Next, we need to know how to do the distributive property with radicals. So here's what we're going to do. We're going to distribute the square root of 2 to the 5 and the square root of 2 to the minus square root of 8. Remember that the 5 and the square root of 2 are not alike, so we can't multiply them together to get a different expression, but we can simply rewrite it as 5 times the square root of 2 minus, now both of these are the same, so 2 times 8 would be 16, and we can multiply them together because they are alike. 5 square roots of 2 cannot be simplified, but the square root of 16 is 4, so we'd have 5 square roots of 2 minus 4. Let's practice distributing again. So I have 2 times 2 and 2 times the square root of 3. 2 times 2 is 4, and then we have 2 times the square root of 3. They are not alike, so we simply have to write it as 2 square roots of 3. In our next example, we're going to continue distributing. So we're going to take the square root of 3 times this expression and the square root of 3 times this expression. So we're going to multiply these together first. And remember, we can only multiply what's alike. The 5 is outside, and so it must stay there. The 3 and the 2 are under the radical, so those can be multiplied together to be the square root of 6. Minus, I have my 2 and square root of 6 and the square root of 3. So the 2 is on the outside, and the square root of 6 and the square root of 3 are underneath, so that's going to be the square root of 18. Then we have to check if we can simplify. 6 breaks down into 2 times 3, 18 breaks down into 9 times 2, and 3 times 3. So when we simplify, we're going to have negative 2 and break that down into 3 squared times 2. So the 3 can come outside, and it's going to be multiplied times the 2, so that's going to be negative 6 square root of 2. And don't forget that we also have our 5 square root of 6. The square root of 6 and square root of 2 are not alike, so we cannot subtract them. That's our final answer. It is simplified and cannot be simplified any further. Now we're going to multiply again and distribute on this example. 3 is the only number out front, so it needs to stay out there. And then we have the 2 and the 24 under the radical, so those can be multiplied together to get 48. Plus, now we have 3 square roots of 2 times 2 square roots of 6. The 3 and the 2 are both outside, so those can be multiplied together. 3 times 2 is 6. And then the 6 and the 2 are under the radical, so 6 times 2 is 12. Now we should make a factor tree to simplify. So 4 goes into 48 12 times. 2 times 2 is 4. 12 is 4 and 3, and 2 and 2. So when I simplify, I have 3, and then I have 2 factor pairs. I have a 2 squared, and a 2 squared, and a 3. So I can bring both of the 2's out of the radical. So 2 times 2 is 4, times 3 is 12, so we have 12 square roots of 3. Then I can make a factor tree, which I already did for 12, as 4 times 3 and 2 times 2. So this is going to be 6 square root of 2 squared times 3. So the 2 can come out, so that's going to be 12 square root of 3. Now these are alike. Since they are alike, we can add them together. 12 plus 12 is 24, but remember to keep the radical, which is the square root of 3. So you're either going to be in or you're going to be out. So if your number outside the radical, you can either be multiplied or divided, and if you're inside the radical, you can be multiplied or divided, but we cannot multiply numbers that are outside times numbers that are inside. Please check to see if radicals are simplified, and then be sure to add or subtract like terms. Please complete the reflection.